to apply those concepts. A double fillet welded lap joint is as shown below. The plate thickness is 12 mm. If the allowable tensile strength of the weld metal is 500 MPa, determine the following. So in letter A, we need to determine the minimum size of the fillet weld. We can refer to the table from NSCP to identify the minimum size of fillet weld. So as per the given, the base plate is 12 mm. So papasok siya dito sa over 6 to 13 mm na thickness ng material. So the minimum size of fillet is 5 mm. Fillet weld is 5 mm as per NSCP 2015. Letter B, total area of the fillet weld. So we know that the tributary area is at the throat. So area is equal to 0.707 times the thickness times the length. So the total area of the fillet weld is 0.707 times the thickness of the fillet weld plus times the length of, this one is the length of 350 mm. So therefore the area is 1,237.25 mm squared. Letter C, capacity of the connection. So since the given tensile strength is 500 MPa, so we'll use this given equals to the force over area. So to determine the capacity, so we need the force P, Ft times the area. So just substitute the given allowable tensile strength of 500 times the area of 1,237.25. Times 1,237.25. So ito class subjected siya sa tensile kasi nga yung fillet weld natin is perpendicular. Perpendicular yung tributary area. So equal siya sa 618.625 kilonewton. Next problem. So in sample problem number 2, a 150 by 90 by 12 mm angular section is welded to a gusset plate as shown. Area of the angle is 2736 square mm. Allowable shear FB is 150 MPa. Allowable tensile stress FT is equal to 0.6 Fy with Fy equals to 248 MPa. So determine the following. Design force P. So we will use the allowable tensile stress FT equals to force over area. Or we can rewrite it as P is equal to FT times the area. Yung tinutukoy dyan class na area is the area gross. So given yung area gross na 2,736. So given yung tensile stress na 0.6 times 248 times the area gross of 2,736. So yung capacity or the design force based dun sa mismong metal base plate is 407.17 kilonewton. So, di ba, from our introduction dun sa prelim, dalawa yung sinusolve natin pagka under tensile forces, yung tensile yielding at saka tensile rupture. So, dito wala tayong makuha para sa tensile rupture. So, mag-govern dito is yung tensile yielding nung base metal. Letter B, total required length of weld using 12 mm fillet weld. So, given na yung thickness ng fillet weld mo is 12 mm. So, pinapahanap is the total required length. So, makukuha natin yan using yung general formula ng fillet weld na Q is equal to 0.707 times the thickness times the length. Naka-Newton per mm pala to. So, times thickness times the FW. But since yung given is the allowable shear, so ito yung gagamitin natin instead na FW. Kasi diba yung isang formula is FW na 0.6 FU. So wala tayong magagamit na FU. So kung ano yung giniven na allowable, so sa fillet weld, mas tend siya sa shear. Kaya yung gagamitin mo is allowable shear. Shear strength na 150. So, 0.707 times the thickness of 12 times allowable of 150 shear strength. So, the answer is 1,272 Newton per mm. But we're not done yet with our solution since yung pinapahanap is the total length. So, yung capacity pa lang to ng fillet weld per linear meter or linear mm. So, yung Q is also equal to P over L. So, yung capacity ng base plate mo is 407.117 kilonewton. So, we'll just substitute the known values. So, yung L natin is equal to P over Q. So, 407.117 times 10 raised to 3 para maging Newton. Then, yung Q natin is 1272.6. Therefore, yung total length, 407.117 over 1272.6 is 91 mm, let's say 320 mm yung length. Then last is the value of B, this one. Ano daw yung length nitong fillet weld na nasa may toe. Pagka sinabi na fillet at the toe, yung tatandaan yung class, ang toe, kung nasan yung hanging nung angle section mo. Tapos ito naman is yung heel, no? At heel. So, okay, let's solve the length B. So, yung gagawin natin to solve this one is mag-moment tayo sa A, no? This one is mag-moment tayo at A. Then, meron dyan mga forces. Ito is force P1. Ito is force P2. So, take a moment at A equal to 0. So, yung P1 natin is unknown times the moment arm. So, yung moment arm niya is yung perpendicular doon sa force. So, equals to 150 minus yung force P na nakuha natin kanina na 407.117 kilonewton times the moment arm na 99 equate to 0. So, P1 is equal to 268.697 kilonewton. So, to solve for the length B, so we will use the Q equals P1 over B. So, we already know the general capacity of the fillet weld na 1,272.6 equals to 268 . 0.697 times 10 raised to 3 para maging Newton over B. So, the value of B (1272.6) is 211.14 mm. So, yan class yung sagot natin. Then, for problem number 4. A flat bar used as a tension member is connected to a gasket plate. Size of weld is 6 mm. With an ultimate tensile strength of 485 MPa. E70 electrodes thickness of plate is equal to 6.25 mm. Use ASD. So the given thickness of gasket plate is 9.5 mm. Fy is 248 MPa. Fw is equal to 0.60 485. Fu is equal to 400 MPa. The connected parts are of A36 steel and assume that the tensile strength of the member is adequate. Determine the strength of the connection per mm considering the design shear strength of the 6 mm fillet weld. So, solve natin yung letter A. Yung pinapahanap class is the strength of the connection per mm. So, to solve this one, use the design shear strength of fillet weld. So, Qn is equal to 0.707 times the thickness times Fw. Kasi malinaw na hinihingi is yung strength connection per mm. So, 0.707 times the thickness of 6 mm times Fw na 0.6 times 485. Sagot natin is 1,234.422 Newton per mm. But, hindi pa to yung final since kailangan natin siyang i-divide sa omega para sa ASD na design philosophy. So, equals to divide to 617.211 Newton per mm. So, ito na yung answer. Then, for letter B, determine the base metal shear strength per mm. So, ngayon naman, yung pinapahanap is the strength naman nung base metal, itong base metal na to, based dun sa shear strength. Ano yung formula natin? So, based dun sa summary natin, pag base metal, so, yung ibig sabihin niyan is yung may thickness na 6.25 mm. No? Ito po yun. Ito. Then, ito naman is yung gusset plate na may thickness na 9.5. So, wag kayong malito sa mga thickness. Kung ano yung ikino-connect nung fillet weld, so, iyon yung base plate natin. So, this one na may thickness na 6.25. So, yung thickness dito is 6.25 mm. So, shear yield strength. So, dalawa yung pagko-compute natin ng shear. Then, saka natin siya i-compare kung ano yung gagamitin na design shear strength. So, Qn is equal to 0.6 Fy since shear yield strength to times the thickness. So, yung Fy na given is 248 times the thickness ng base plate mo na 6.25. So, kung mapapansin mo, yung thickness ng base plate mo is malaki compare dun sa fillet weld. So, hindi dapat sobra sa thickness ng base metal yung thickness ng fillet weld. Is equal to 0.60 times 248 times 6.25. Since kailangan natin class is based sa ASD na design philosophy, so magdi-divide tayo ng 1.5. So balikan nyo na lang yung mga safety factor dun sa summarized version. 1.5 is 620 Newton per mm. Then, di pa tayo tapos. Kumpitin naman natin yung shear rupture strength. Per mm. So, Qn is equal to 0.6 Fu times T. 0.6 yung Fu ng base plate is 400 MPa. Ay, hindi. 400 MPa. Kasi yung, sabi daw dito, yung connected parts are 836, no? Yung base plate. So, 400 yung Fu niya times the thickness of 6.25 over, again, the safety factor of 2 para sa rupture naman. 0.6, 400 times 6.25 na 750 Newton per mm. So, sa pagpili, dito sa dalawang values, yung pipiliin nyo is yung smaller one. So, ito yung sagot natin. So, ilagay ko lang 1.5 dito. Yung delta niya sa design philosophy ng ASD is 2 para sa shear rupture. Next, letter C. Letter C na tayo. So, letter C, determine the available strength of the connection. Diba yung nagko-connect sa metal base plate natin is yung welds tong welds na to. So, pinapahanap is yung available strength niya, which is Q is equal to P over L. So, strength ng connection. Q is equal to P over L. Okay? Yan. So, nasolve na natin yung design strength ng fillet weld per mm. So, yung kailangan dito class is yung P. So, just substitute yung una nating nasolve na 617 para sa fillet weld equals to unknown P times yung length ng mga fillet weld. So, dito, ito yung mga connected, 100 plus dalawang, 100 plus dalawang 150. So, yung total length niya, 100 plus 2 times 150 is equal to 2 times 150 equals to 400. So, 400 times 617.211, 246.884 kilonewton. Then yung isang formula, so kung babalikan natin class dun sa pag-compute ng design strength ng connection, di ba dalawa yung kailangang computein at saka pipiliin natin yung malaki. So, itong letter D. So, meron na tayong isang na compute. So, yung pangalawa naman, yung yung P is equal to Q times 0.85 times LL plus 1.5 QLT. Yung pangalawa is P is equal to 0.85 Q times L sub L plus 1.5 Q times L sub T. So, substituting the values, 0.85 times yung Q natin is 617.211 times itong L sub L. Yung binabanggit dyan is yung longitudinal length ng welds. Yung dalawang 150. No? Ito po yan. Ito po yung longitudinal length. L sub L. Then ito naman yung L sub T. Ito L sub L din. So, dalawang 150. So, equals to 300. 300 plus 1.5 times Q, 617.211 times transverse length of 100. So, equals to 249.970 kilonewton. So, dito naman, yung pipiliin mo is yung bigger one. So, ito yung sagot